Question 1 says that use the substitution y equals to vx, where v is a function of x, to transform the differential equation x squared dy over dx equals to x squared plus xy plus y squared into a differential equation in v and x. Hence, find the solution of this differential equation given that y is 1 when x is 1.
We should keep moving. They'll find us soon. We need to get out of here. We need to get to that house. We'll have a better chance of fighting them from there.
Come in, Kirk. The locals were hostile and we had to use force. We don't have any contingency plans for this situation, do we, Kirk?
Roger on the locals, but your orders still stand.
What does that mean? Was HQ expecting this?
So when we look at this, we see that this is a homogeneous differential equation, and to get a solution of this homogeneous differential equation, we are going to use the substitution method. Since the equation already gave us the substitution we are going to use, therefore they have eased our work. So we're just going to use what the equation gave us. So we have our substitution here. We're going to use this, and the function is with respect to x. It's a function of x, so we need to take note of this. Now from here we know that, let's just copy our homogeneous equation. Okay, now after copying that, to solve this, we are going to divide all through by x squared. Divide all through by x squared. Divide all through by x squared and x squared there. So that here we are going to have dy all over dx equals to 1 plus, here we are going to have y all over x, and here we are going to have y all over x. Now all of that squared, so here we have this, but we have to take note of something. Our substitution was y equals to vx, so this simply means that our dy all over dx, since it's a function, is differentiated with respect to x, will simply be equals to x dv all over dx. The same reason we're differentiating with respect to x, plus v. So anywhere we see dy dx, we can simply substitute it with x dv all over dx plus v. We also see that our v is that, so we're going to keep that very well, and also keep this very well, so that
You grab it.
Okay.
Come on, take
You
it.
need to be careful.
Thanks for the help.
You don't know what you're talking about! You can all go to hell!
Wait a minute. That's the...
Tipo, what? Now to Suia. Hapo ndani! Wawe wote! Wacha wawe toleo ya damu ya njia zetu! Wawe!
Now coming back to this, we're going to substitute v and divide the x. So we have our x dv all over dx plus v equals to 1 plus v plus v squared. So we have that. We see that v will simply cancel with this v and we will be left with x dv all over dx to be equal to 1 plus v squared. So if we divide or through by let me say if we multiply or through by dx, so we are going to have x dv equals to 1 plus v squared dx, and we decide to divide all through by 1 plus v squared, 1 plus v squared, and x and x. Then we notice that here it's going to cancel and x is going to cancel, so we'll be left with dv all over 1 plus v squared equals to dx all over x. So we're going to take our integral on both sides. So when we take our integral on both sides, then we're going to have the integral of this of with respect to v here will simply be tan inverse, will simply be the tan inverse of v. So this will be equals to the ln of x, the absolute value of x, the ln of the absolute value of x plus our constant k. Now this is what we have, this is what we have, and we see that we have transformed our differential equation in terms of v and x.
come in. The locals are hostile. The gate is sealed, and we're trapped. We need backup, and we need it right now.
Roger that. Just sit tight. I'm on my way.
Did you hear that, Sheva? Help's on the way.
Got it. I just hope he gets here quick.
But we have to transform. Since we know that our v is y all over x, then we're simply going to put it here. So we have tan inverse of y all over x will simply be equal to the ln of the absolute value of x plus k, so that our y on x so if we look at this, so that our y all over x will simply be the tan of the ln of absolute value of x plus k. So if we like, we can multiply all through by x to have x tan the ln of the absolute value of x plus k. Now let's look at something. We're given conditions that y is 1 when x is 1. So from here we know that our v will simply be 1. So even from here we can get our value of k. From here we can get the value of k, so that the value of k will be tan 1 to be equals to the ln of 1 plus k. We know that tan 1 is 45, which is pi on 4, so our k is pi on 4. So this is our value of k. Therefore we're simply going to put our value of k in this equation to get our solution, our final solution. Therefore the final solution of this question is y equals to x tan of the ln of the absolute value of x plus our constant k plus pi on 4 So that's our solution for this question. Okay guys, if you want more of this kind of videos, please subscribe to my channel. If this video was helpful in one way or the other, please like and subscribe. You can also share with those in need of the video. See you guys in the next video.
until Kirk gets here.
I need ammo.
Come on!
Roger.
Take it!
Okay.
Take it!
Okay. I owe you one. I owe you one. Help me!
Chris, Sheva, how you holding up? I'll be there shortly. Just hang in there.
I need ammo.
Sorry to keep you waiting. I'm gonna take out the door. Find some cover.